Okay, let's take a look at number 13 on page 125. A design team determines that a cost-efficient way of manufacturing cylindrical containers for their products is to have the volume V in cubic centimeters modeled by this equation, where x is an integer between 2 and 8. The height h in centimeters of each cylinder is a linear function given by h of x equals x plus 3. Determine the quotient v of x divided by h of x of that expression and interpret this result. Okay, what we're going to do is we are going to determine the quotient using synthetic division. So I have plus 3 and my coefficients to work with are 9 pi, 51 pi, 88 pi, and 48 pi. Okay, so what we have now is we bring down the 9 pi. 9 pi times 3 is 27 pi, and we're subtracting. So 51 pi minus 27 pi is 24 pi. 24 pi times 3 is 72 pi. Subtracting 88 pi minus 72 pi, we get 16 pi. 3 times 16 pi is 48 pi. So we have a zero remainder. So what we have is the expression that represents the base of the cylinder. Is 9 pi x squared plus 24 pi x plus 16 pi. So it's the area of the base. I'll put area of base of the cylinder container. Okay. Use your answer in part A to express the volume of a container in the form pi r squared h. Okay, so if we take a look at the answer in part A, we have v of x is equal to 9 pi x squared plus 24 pi x plus 16 pi by x plus 3. Okay, taking out pi as a common factor, we have 9x squared plus 24x plus 16 by x plus 3. So we need to use decomposition to break down 9x squared plus 24x plus 16. So to do that, I'll just give you a reminder on decomposition. 9x squared plus 24x plus 16. So something times something equals 9 by 16, which is 144. And those same numbers have to add up to the middle term of 24. So those numbers will be 12 and 12. So we have 9x squared plus 12x plus 12x, decomposing the 24x, plus 16, factoring by grouping, we have 3x by 3x plus 4, plus 4 by 3x plus 4. So this is equal to 3x plus 4 squared. So v of x equals pi by 3x plus 4 squared by x plus 3. So v is equal to pi r squared h. So in this factored form, express the volume in the form of pi r squared. Okay, so in factored form, 3x plus 4 represents the radius, and x plus 3 represents the height, which is h. Okay, part C. What are the possible dimensions of the containers for the given values of x? Okay, well, we were given that x is between 2 and 8. So for the radius, which is 3x plus 4, we simply substitute our boundary numbers. 3 times 2 is 6 plus 4 is 10, is less than or equal to r, is less than or equal to 8 times 3 is 24, plus 4 is 28. So the radius is between 10 and 28. For the height, we have the expression x plus 3, so it will be 2 plus 3 is 5 centimeters, and a maximum of 11 centimeters. So in sentence form, for the given values of x, the radius can be from 10 centimeters to 28 centimeters, and the height can be from 5 centimeters to 11 centimeters.